Hi, I am R. Venkatesh, Assistant Professor in the Electronics and Communication Engineering Department at Rogani College of Engineering and Technology, Anjigramam, Palkulam, Kanyakumari District. Now I am going to present a topic in the optical communication, that is overview of SONET layer and SDH. After the completion of this topic, student will be able to explain about the basic concept of SONET bar SDH layer and its frame format and the protection mechanism which is used in SONET bar SDH. Introduction. SONET, Synchronous optical network in an optical transmission interface with TDM optical network. SDH, Synchronous digital hierarchy, is a synchronous network. For why we are using SONET bar SDH in optical communication network. The SONET bar SDH format allows different types of signal format to be transmitted over the fiber optic cables. It allows adding or dropping of signals within a single multiplexer. Communication between various localized network is a complex due to different in signal hierarchy, encoding techniques and multiplexing strategies. Communications between TDM network requires complicated multiplexing, demultiplexing, coding and decoding to convert a signal from one format to another format. So to solve this signal conversion problem, SONET brings a standardizing in bit rates, framing format, signaling and transmission between SONET equipment. So SONET is a set of standard interface in an optical synchronous network of elements that conform to these interfaces network. Similarly, SDH is a set of standard interface in a network of elements that conform of this interface in a SONET network. So SONET bar SDH interfaces defines all layer from physical to application layer. Similarly, it is used in OSL format. So SONET bar SDH defines a synchronous frame structure for transmitting TDM signals in an optical fiber network. So, SONET is an named for synchronous optical network which is used in North America, and SDH is a named for synchronous digital hierarchy in other part of the world. So it allowed different types of signal format to be transmitted over the fiber optic cables, and it allows adding and dropping of signals within a single multiplexer by using TDM technology. So SONET bar SDH encodes bit streams into optical signals that propagate over an optical fiber. So SONET is a high-speed network and it frame structures permitted to support a very flexible set of peer services in all type of networks. So in general, to solve this problem, the standardizing has been taken to place in bitrate, framing format, signaling level, terminals equipments that should be used in the optical communication network. So SONET is defines a hierarchy of signal levels by synchronous transport for STS1 to STS768 level. Similarly, SDN is defines a hierarchy of signal levels for synchronous transport model from STM1 to STM256 signal level. The transmission formats will be depends upon their architecture of SONET bar SDH layer. So here we see the SONET bar SDH layered architecture. It consists of four different layer, that is path layer, line layer, section layer, and the photonic layer or physical layer. So path layer, it completes an end-to-end connection and it deals with the transport of services between the PTE layer. Its main function is to map the signals into a record format by line layer, that is reading, interrupting and modifying of signals levels that is required by the line layer. Next layer will be the line layer. It provides a longer link that connect two SONET devices, and it deals with the transport of path layer, payload envelope and it overhead across the physical medium which is required by the section layer. And it maintains the main function is protection, switching, line maintenance and error monitoring which is occur in the network process. Section layer. It connects adjacent pieces of equipment which is required in the network connection and deals with the transport of STS-N frame formats, and its main function is framing and scrambling. Photonic layer. It mainly deals with the transport of bits across the physical fiber medium. The main function is conversion of signal between STS-N to OCN signal level. Here, the transmission path, format and its speed is depends upon the equipment which is used in the SONET layered network. That is, we are using three different types of equipment. One is PTE and another one LTE and the last one STE. PTE is the path terminal equipment, LTE is the line terminal equipment, STE is the section terminal equipment. So in the in the linear multiplexing and demultiplexing is possible by using add drop multiplexer. So that add drop multiplexer is fully synchronous one with byte oriented devices that can be used add and drop OC signals subchannels within OCN signals. Next, we are going to see the frame format of SONET layer. Here, two different types of frame format will be used. One is STS frame format and another one is STM frame format. So, in the frame format, the transmission format and speed will be depends upon the two signal modules, that is synchronous transport signal and another one is synchronous transport module STS and STM. STS SONET defines a hierarchy of signaling level that called synchronous transport modules STS. Similarly, STM synchronous transport module is a SDH. SDH defines a hierarchy of signal levels which is called by a synchronous transport module STM. In the frame format, two it is a two-dimensional structure which contains 90 columns by 9 rows which of total 810 bytes. In STS1 SONET frame, the first three columns which will be occupied by TOH, that is transport overhead process, and remaining 87 columns are which is used by section synchronous payload envelope SPE. So in SPE, it is used for user data and details about the charges and the payment required for the transmission. And another one layer, only one column which is present in SPE, that is POH, path overhead. The 9 path overhead bytes is always in a column and can be located anywhere in SPE. Thus, POH support performance monitoring by the end equipment's status, signal labeling and tracing functions and is used in the channel. In the bit rates, STS1 frame format is equal to 90 column of bytes into 9 rows of bytes, that is totally 810 bytes. In a frame of 125 microseconds in duration, which corresponding to 1 8 kHz voice sample. Let us take as an example of STS1 rate will be 51.8.4 megabits per second. Then we calculated it will STS1 frame will contain 51,840 megabits per second amongst frame 1 to frame 8000. So one frame contains 810 bytes. Similarly, that is 810 into 8 byte is equal to 6480 bits. Within 1 second, 8000 frames will be transmitted. So the total data rate of STS 1 frame is equal to 6480 into 8000, that is equal to 51,840 megabits per seconds of data will be transmitted in a single STS frame. Thank you.